All right, so I want to take a look at questions 15, 16, and 17. We're going to save 18 for last. That one takes a little bit of time. So for number 15, guys, if you just go to your calculator, and if you go math, num, and then ABS, you'll be able to find the absolute value. So on the TI-83s, you'll have that parentheses. You'll need to close the parentheses. Don't forget that. And your symmetric table of values should look like the following. Remember, guys, you're looking for it to be symmetric about a point. Okay, so just to comment a little bit on this, if you look at the values here, 3, 2, 1. Notice how it goes 1, 2, 3, 4, 3, 2, 1. The 3s are symmetric, 2s, and then the 1s. It's symmetric about this point. That point right there of -1, 4. Anyone remember what that's called? If it's changing direction on either side, that's going to be called our vertex. Now, more specifically, guys, that's our vertex, or the turning point. Is that going to be a max or a min? Think about what's happening on either side of the points. Very good. This is going to be a maximum. Maximum. If you look at the values, guys, they're getting smaller on either side. You go from 4 to 3 to 2 to 1. You go 4, 3, 2 to 1. 4 is the max value. All right, let's take a look at number 16. So I want you to factor this expression. So we always need to look for a GCF first. So based off of looking at this, I think the GCF is going to be 6. So I want to divide out everything by 6. So I'll divide everything out by 6, and that stays out on the side. What's left in our parentheses is x to the 4th minus 16. Now, are we done? Is this factored completely? Well, let's see. I have x to the 4th minus 16. I have 2 perfect squares, and I have subtraction in the middle. This is going to be dots, guys. I have 2 perfect squares and subtraction in the middle. Okay, well, let's do dots. I've got 6 times x squared minus 4 times x squared plus 4. All right, are we done? All good? Anyone notice anything? Is this factored completely? We have another dots. We have another dots right here with my x squared minus 4. That is a difference of 2 squares again. So this is actually going to break up. This is dots again, guys. Dots again. Doesn't go away. All right, so let's do this. I've got 6 times the square root of x squared. We've got an x and an x. Square root of 4 is plus or minus 2. And then I'm going to bring down the x squared plus 4. This is not dots. Not dots because of the plus sign. The plus sign in the middle means it can't be dots. Has to have subtraction, as we did over here. All right, great. Let's move on to the next question, number 17. All right, so question number 17 says, what is the common difference? Common difference, guys. We're talking about a fixed amount. So this was arithmetic sequences. This is a fixed amount, and we called that letter D, lowercase d. Okay, so let's look as I go from x plus 1 to x plus 4, x plus 4 to x plus 7, and x plus 7 to x plus 10. What are they all going up by, guys? Nothing's happening to the x's. All the x's are staying there. What are they all being added by? I went from 1 to 4 to 7 to 3. Yeah, they're all going up by 3. So the common difference here is 3. That's it. Done.